Welcome to The Explainer. Today we're jumping into a classic problem in software development, one that's just as real today as it was decades ago. We're going to be pulling some serious wisdom from Fred Brooks's legendary book, The Mythical Man-Month.
All right, let's kick this off with a quote that Fred Brooks himself used to set the stage. This idea of crowding a whole lot of stuff into a tiny space, well, that's pretty much the soul of the challenge we're talking about today.
So, here it is, the big question. This isn't just some old-timey saying. It's the absolute core of the problem. How in the world do you build powerful, feature-packed software that doesn't end up being a bloated, slow, expensive mess? I mean, this is the puzzle that keeps developers up at night.
To even start to figure that out, we have to get our heads around where the real costs are hiding. It's so easy to think the price of software is just, what you pay for the license. But the reality? Oh, it's way more complicated than that.
The thing is, the space a program hogs isn't free, not by a long shot. Whether it's taking up room on your hard drive, eating up RAM, or running in the cloud, that space has a real ongoing cost, and it's every bit as important as how fast the program actually runs.
And check this out. This is a perfect example from back in the day with IBM's APL system. The software itself rented for $400 a month. Not too bad. But the memory it needed, just 160 kilobytes, cost nearly 5 times that much. We're talking over $1,900 a month. The space was way, way more expensive than the code itself.
And that just highlights an even bigger idea. People would see a number like this, almost $5,000 a month, just for the memory an OS was using, and they'd complain about how ridiculously expensive it was. But Brooks's point is, that's kind of like criticizing a 747 for being expensive. The real question isn't what it costs, it's what do you get for that cost? Is the value there?
So here's the big lesson. Size itself isn't the enemy. Unnecessary size is. A program can be huge as long as it delivers huge value. And that puts all the responsibility right back on the managers and developers to set size targets and actually stick to them, just like a hardware engineer has to control every single component on a board.
Now let's look at a famous case study to see what happens when this goes horribly wrong in the real world. This is the story of OS 360, a massive project Fred Brooks himself was in charge of, and how a complete failure to control size almost brought the whole thing crashing down.
So here's the play-by-play of the disaster. The goal was this amazing new operating system, but management made one critical mistake. They only set size limits for the code that was in active memory. So what did the programmers do? To meet their targets, they just chopped their code up into 1 million tiny pieces, called overlays, and stored them on the disk. The result? A total catastrophe. The system was spending all its time just pulling these little pieces from the disk, slowing down to an absolute crawl. We're talking 5 statements compiled per minute. Useless.
What was happening was basically the software version of page thrashing. The system was just spinning its wheels, right? Constantly swapping bits of the program between the disk and memory and not getting any actual work done. And the crazy part is, every single programmer had successfully met their individual size goal, but together they'd built a system that was completely and utterly broken.
So, after that near-total disaster, what did they learn? Well, they pulled some really crucial lessons from the wreckage, principles that are still vital for any big project today.
The morals were crystal clear. First, you have to budget for everything. The total size, the disk access, not just what's sitting in memory. You've also got to define exactly what a piece of code is supposed to do, along with how big it can be, so people can't just push the problem somewhere else. And maybe most importantly, you have to kill that brownie points mentality, where everyone's just optimizing their own little piece of the puzzle. You need everyone focused on the total user experience.
But rules and budgets from the top are only one part of the equation. Making a program lean and mean really comes down to the creativity and the craftsmanship of the individual programmer. And every programmer has this one fundamental tool in their belt, the space-time trade-off. It's a basic law of the universe, really. If you want something to run faster, you usually have to give it more memory to work with. The real art is knowing exactly when to make that trade and how much to trade. And a really smart manager can help their team with this. How? By creating what Brooks called a technology notebook. For all the common tasks, things like searching or sorting, this notebook should have at least 2 versions ready to go. A quick version, built for pure speed, and a squeezed version, built to be as small as possible. This gives programmers the right tools to make the right trade-offs for whatever they're working on.
But here's the thing. All this tactical cleverness, it's super important, but it'll only get you so far.
The biggest wins, the programs that are truly elegant and lean, they don't come from just tactics. They come from a big strategic breakthrough.
Now, don't get me wrong. A new algorithm can be a game changer. But Brooks argues that more often than not, the real, revolutionary leap forward comes from something way deeper. It comes from completely rethinking how your program represents its data in the first place.
And this quote from Brooks just nails it. It's one of his most famous. A program's logic, its flowcharts, its code, that's all secondary. The real heart, the essence of a program, is in its data structures, its tables. If you get the data right, the code just falls into place. It becomes obvious.
And that's the key right there, representation. Brooks says the most powerful thing a programmer can do when they're totally stuck, out of space, out of time, out of ideas, is to just stop coding, step away from the tangled mess of logic, and just think about the data. Rethinking how it's all structured, that's where the magic really happens.
So that leaves us with a pretty powerful question for anyone out there who builds things. When you're facing a really tough problem, are you getting tangled up in the weeds of your code? Or are you taking a step back and truly contemplating the fundamental structure of your data? Because as Fred Brooks taught us, that's almost always where the real breakthroughs are hiding.